Okay, so how to find real zeros of a polynomial function. There are a few steps you would take with this. So find the real zeros of f of x equals 3x to the third negative 5x squared minus 4x plus 4. And then we want to write f in factored form. So first off, we want to use the degree to determine the maximum number of real zeros. And the degree of the function degree is n equals 3 because our highest degree is 3. So that means the max possible real zeros is 3. Okay? Don't forget, it can be less than 3, but it can never be more. Okay? So now we want to use the rational zero theorem to determine possible rational zeros. So we know that positive 4 is our p-value, 3 is our q. So the factors of 4 are plus and minus 1, plus or minus 2, and plus or minus 4, because 1 times 4 is 4, and 2 times 2 is 4. We only need to list it once. For q, which is 3, our potential factors are plus or minus 1 and plus or minus 3. So our potential real zeros, p divided by q, would be 1 divided by 1, so that would be plus or minus 1. 1 divided by 3, so that would be plus or minus 1 divided by 3, because we cannot reduce it. 2 divided by 1, so 2 divided by 1 is 2, so that's plus or minus 2. 2 divided by 3, we can't reduce, so it's going to be plus or minus 2/3. 4 divided by 1 reduces to 4, so plus or minus 4. And the last one, 4 divided by 3, cannot be reduced, so it would be plus or minus 4/3. So the third step is we want to use a graphing utility to locate possible zeros. So when I put this in Desmos, you could also put this in the TI-84. The green dots are where our potential zeros are. So this zero looks like it is at -1. This one appears to be at 2. And this one right here, if you look, it's not halfway, it's a little more than halfway. So I'm going to guess it's about 2/3. So the zeros appear to be at -1, 2/3, and 2. So by using this graphing utility, it kind of gives us a hint of where to start before we do our synthetic division to see if it really is a zero for the equation. So our next step is we want to determine if the potential rational zero is really a zero. We're going to use the factor theorem. So I'm going to go ahead and paste what we thought appeared to be zeros based on our graph. And then we are going to use the synthetic division to check. Okay, so I'm going to first use the -1. Okay, and then looking at my equation up here, I know that the top part of my synthetic division is 3, -5, -4, and +4. Okay, so the 3 comes down. -1 times 3 is -3. -5 plus -3 is -8. So -1 times a -8 is a +8. -4 plus 8 is +4. -1 times 4 is -4. And 4 plus -4 is 0. So we know that when x equals 1, -1, it really means x plus 1. So therefore, x plus 1 is a factor. Okay, so that is a factor in our equation. Now, what we end up with at this point is x plus 1 times, and in the parentheses, okay, so if we look, we know this started with x cubed. So that means this down here starts with x squared. This is x, and that's the constant. So it would be times 3x squared minus 8x plus 4. That is what it would look like with x plus 1 factored out. So we have two choices here. On the next one, we could do synthetic division again, or since this is only a squared, we could probably just factor it the normal way to where we keep the x plus 1 and then factor it out. So I know x squared, 3x squared has got to be 3x and a single x. So with 4, our choices are going to be 1 and 4, 2 and 2. Those are the factors of +4. Also, it could be plus or minus on both of them. Because our middle one is negative, that means, and this is positive, when it multiplies, it has to be positive. So we're going to use the negatives. So we're going to use -1 and -4, or -2 and -2. So I know if I do 4 times 3 is 12, and 12 plus 1 is 13. So that's not going to work. And adding 3 and 4 doesn't work. So it's going to have to be 2, because 2 times 3 is 6, 2 times 1 is 2, and 2 plus 6 is 8. And we know that it's going to be negative for both of them. So that our factors for f of x would be x plus 1 times 3x minus 2 times x minus 2. That would be the factored form of the equation. Now, if I wanted to, just to show you what it would look like with synthetic division, I could take and do synthetic division with this second one. So I could take, let's say, the factor of 2. Okay, let's take the x minus 2 factor, which is just x equals 2. So I could put the 2 here, take down the 3, the negative 8, the positive 4, and 3 comes down. 2 times 3 is 6. Negative 8 plus 6 is negative 2. 2 times negative 2 is negative 4. And we can see that x minus 2 is a factor. We know that this becomes 3x minus 2. So we get the same factors as when we factored it out on our own. So if you're more comfortable doing synthetic division, you can do a check and guess using synthetic division. And remember, x minus 2 is the same as saying x equals 2. That was one of our potential factors up here. And then 3x minus 2 becomes 3x equals 2, x equals 2/3, and that was our other potential factor. So we have proven that all three of our potential factors are in fact factors of f of x equals 3x cubed minus 5x squared minus 4x plus 4.